In this video, we're going to be going over problems known as two-step mole conversions. It will be very helpful if you were writing down the problems that I'm working out. It would also be pretty helpful if you had your mole conversion sheet like this one here. If you don't have this, I would definitely make sure that you pause the video and copy this down because I'm going to be referring to this a lot during the problems. So let's first talk about what you guys have done before, and then we'll talk about how it's going to be a little bit different when we're working out the problems today. So in the past, you have done what are called one-step mole conversions, which is where you start with one unit on this sheet, either grams, moles, or numbers of particles, and you converted to the one that was right next to it. That's a one-step problem. So for example, some problems you started out with grams and you just had to convert it to moles, and when you did that you would have to use the molar mass. You'd have to divide by the molar mass. And on the flip side of that, some problems you started out with moles and gone to grams, again using the molar mass, but in that situation you would just need to multiply by the molar mass. Other problems you've done, you have started out with particles, either atoms, molecules, or formula units, and you've converted it to moles using Avogadro's number. In that situation, you would have had to have divided. Or on the other side of that, you start out with moles and converted it to particles, again using Avogadro's number, but in that situation, you would need to multiply. So those are all the one-step conversions you've done. So that's 4 different types of problems that you had to learn how to do. In this video, we're going to learn what are called two-step conversions, meaning you are going to start either with grams and convert to first moles and then to particles, or you're going to start somewhere on this end, either atoms, molecules, or formula units, and first convert to moles and then to grams. So these are a little bit trickier, and you're definitely going to have to be very comfortable with this guide because these are a little bit harder. So you can either start with grams and go to particles, or other way would be starting with particles and converting to grams. So I'm going to be working out one of each of those problems. So if you look there, that is 6 possible problems that you're going to be responsible to know how to solve on your test. So let's look at an example. So here I have a grams to particles problem, and I first want to talk about how you can recognize a two-step problem. So in this problem, it says how many molecules of bromine are in 313.5 grams of bromine. So we're starting out with 313.5 grams of bromine, and it wants to know how many molecules is that. So you're starting out with grams and you're trying to convert it into molecules, which is a particle found in a mole. So if you look at your conversion chart, you're starting out with grams, and if you look, you have to convert first to moles in order to get over to molecules. So you know that you're going to have to do 2 steps because they're not right next to each other on that chart. So you're going to first convert from grams to moles using the molar mass. Okay, in that situation, we're going to have to divide by the molar mass. And then, when we get to moles, then we can use Avogadro's number to convert it into molecules. And in that step, we're going to have to make sure and multiply by Avogadro's number. So these are the steps that we're going to have to take. So let's start our dimensional analysis chart. So we have 313.5 grams of bromine. Now in your charts, I want you to make sure and put the right formula for the compound that you're converting. So this compound is known as bromine. Now bromine, you would think that it's just Br because that's all there is in the name. But bromine is actually one of your diatomic elements, so make sure that you guys don't forget Br is never just alone. He comes in a 2Z, also called diatomic. Okay, so start your chart with what they give you in the problem. And we are first, according to our steps right here, we have grams and we want to first convert to moles. So the unit that you're trying to get to goes on the top of your next step. So what unit comes down on the bottom? Well, if you look, grams is on the top right here. Automatically grams gets to come down on the bottom. So there's your first step. Now how do you know what numbers go with those units? Well, the number that always goes with moles is a 1. You always have 1 mole when you're doing your conversions. Then what number goes with grams? Well, if you look, when we go from grams to moles, we have to use the molar mass. Molar mass always goes with grams. So we have to look at our periodic table and figure out what the molar mass of our compound is. In this situation, we have Br2. So Br2 means we've got 2 bromines, so we need to look at the periodic table. Periodic table says that bromine weighs 79.9, so I'm going to do 2 times 79.9, and that will get me the molar mass, and what that number is going to be 159.8, and that's the number that I put with grams. So in that first step, we've gone from grams to moles, and we have used the molar mass. Well, we're not finished because we need to get all the way over to molecules, so our next step, we have moles and we want to get to molecules. So that's the unit that will go on the next step. The one that goes on the bottom, we'll look at the top of the last step. Moles is on the top of the last step, so it's going to come down here on the bottom on the next one. When we're doing our conversions right here, setting them up, 1 always goes with mole. And so what number goes with molecules? Well, when you go from moles to molecules up here, it says that we need to use Avogadro's number. You guys just have to memorize that Avogadro's number is 6.02 times 10 to the 23rd. So another way of looking at these dimensional analysis charts is when they are above and below each other like this. That means they equal one another. So how many things is always in 1 mole? Well, we always have Avogadro's number in 1 mole. Same thing applies to this step. 1 mole always equals the molar mass of that compound. So in this situation, the molar mass equals 1 mole. So that's another way of looking at our dimensional analysis charts. Okay, so we have it filled in. We've gone from grams to moles, moles to molecules. So now we just need to type this into our calculator and get the answer. So another thing I'm seeing that you guys are struggling with is typing this in your calculator. You don't know what to type in once you filled this in. So the rule is everything across the top needs to get multiplied and everything across the bottom needs to get multiplied. So everything left to right has to get multiplied. Then top divided by bottom. So at the very end, you'll do top divided by bottom. So on my calculator, this is exactly what I would type in. The numbers across the top, so 313.5 times, now I'm going to ignore ones in all of these situations because if you multiply or divide by 1, it's not going to change a thing. So there's no reason to waste our time typing ones in. So I'm just going to do 313.5 times 6.02 times 10 to the 23rd. So I don't type it in my calculator using the times 10. I use the E. So don't forget, the E, if you want to get that on your calculator, you push second, and then you push the button that is right above the number 7, and it looks like this. Okay, so X to the -1. That looks pretty crappy, sorry. So that's how you get your E. So we're going to multiply all of those across the top. So 313.5 times 6.02 e to the 23rd. Divided by the number that's on the bottom is 159.8. I'm not going to multiply that with the 1 because it's not going to change anything. So see, we multiplied everything across the top, and then top divided by bottom. You type that in your calculator, you're going to get a really long number like this. And I want to show you guys really quickly a problem that I'm seeing on a lot of your quizzes and worksheets is that you get your answer, but then you ignore this right here at the very end, e to the 24th. Okay, that is part of the answer. Okay, you need to make sure that you do not ignore the very end. That just means it's in scientific notation. So I would write that, and I would just round it 2 decimal places, 1.18 times 10 to the 24th, and then do not leave it like that because it doesn't have a unit. So how do you know what your unit is for answer? Well, you could simply just look back up in the problem and it says you want molecules. So it should be molecules, but let's make sure we did this right. If you look in your chart, grams is on the top and on the bottom, so it's going to cancel out. Moles is on the top and on the bottom, so that's going to cancel out. And what we're going to be left with is molecules, so we did it right. We got the right unit, and you've shown your work, plugged in everything right in your grid, so that should be correct. 1.18 times 10 to the 24th molecules. So let's look at another problem. In this problem, we're going to be going from particles to grams. So let's see how we actually know that this is a two-step problem first. So it wants us to calculate the amount in grams found in 7.5 times 10 to the 52 atoms of carbon. So it gave us 7.5 times 10 to the 52 atoms, and it wants us to figure out the amount in grams. So this is a particles to grams problem. So if you look at your chart or your conversion guide, you start with atoms. You cannot convert to grams in just one step. You have to first convert into moles using Avogadro's number. And then once we get to moles, then we can use the molar mass to convert into grams. So this is how you know that you've got a two-step problem. So we're going to start our chart. 7.5 times 10 to the 52 atoms of carbon. Now carbon, whenever you see this element by itself, that is not diatomic. That is just one carbon atom. So we're just going to write a capital C for carbon. Start your chart. Okay, so we start out with atoms, and it says we want to go from atoms first to moles. So the unit you're trying to get to comes up here on the top. And the unit that you're trying to get away from is atoms. You're trying to convert from that to moles. So atoms will come down here on the bottom. And the number that always goes with moles is a 1. So how many atoms is in 1 mole? Well, you have to use Avogadro's number, and there's always 6.02 times 10 to the 23rd atoms in 1 mole. So that is the number that goes with atoms, and 1 goes with moles. If you notice on all of my charts, I always write my units before I write my numbers. You should get in this habit as well. So we've gotten to moles. Now we need to convert into grams. So we're going to get to grams by putting that unit on the top. And then the unit that was on the top of this step comes down on the bottom on the next step. So the number that always goes with moles is a 1. So how many grams of carbon is in 1 mole? Well, that's the molar mass. And according to our guide, we have to use the molar mass when we go from moles to grams. So if you look at the periodic table, 1 carbon atom only weighs 12.01. So that right there is the molar mass. That goes with grams. Remember, molar mass always goes with grams. So multiply everything across the top, ignore the ones. Multiply everything across the bottom, ignore the ones, and then top divided by bottom. So in our calculator, we would type in, put a parentheses around it so that your calculator does this right, 7.5. Instead of times 10, I'm going to use the E, push second and the button above the 7, and then put the exponent right behind it. So I'm going to do that number times 12.01. Ignore that 1. Close parentheses up and then divide by what's on the bottom. We don't need to multiply anything across the bottom because it's only one number multiplied with a 1. Avogadro's number is 6.02 e to the 23rd. So if you type that in your calculator, again, you're going to get a really long number. But again, I want to draw to your attention, a lot of you will see this. You'll see times 10, and it'll have the exponent here. So do not ignore this. This is part of the answer. So we're going to round to 2 decimal places. In this situation, I have a 6 behind this 9. So I'm just going to round all of this up to 1.50 times 10 to the 30th. That is part of the answer. I have to include that. And so what's my units? Well, atoms canceled out because it's on the top and the bottom. Moles canceled out because it's on the top and the bottom. So I'm left with grams. If If you look in the problem, it says that it wanted us to figure out the number of grams, so we are finished. So if you are struggling with these problems, I would suggest watching this video over again. If you are struggling with just the simple one-step problems, there is a video called One-Step Mole Conversions that will help you with those. See you in class.